Estimate the area under a curve, so you will have one of these. Okay, so what do I know if I want to just kind of quickly sketch that? Anybody know what's going on? It's a parabola, opens up. Should we factor this maybe? That might be. If I GCF, what do I know about the x-intercepts? 0 and 2. Okay, that's a general understanding. Okay, so that will help. Okay, I'm going to go from 2 to 10. And I have to chop it up into 4 sections. I have to do that to it. I have to chop it up into 4 sections. So this will be a 4, a 6, and an 8 as x values. Does that make sense if I do that? So each one is going to be 2 wide, each section, right? Sometimes they might be 1 or 3 or 2, so just be careful with that. Okay, why don't we just get a bunch of info here? Let's plug in 2, 4, 6, 8, 10. Okay. Do you want me to cheat and do this or what? Okay. So I'm going to go, if I put 2 in, actually no, I'll just really cheat here. X squared minus 2x. Okay, so there's our graph. Ready? At 2, you're at 0. Oh, we knew that. At 4, your height is 8. At 6, 24. At 8, 48. 10, you're at 80. Okay, everybody knows how to plug them in though, right? You just go, if you're plugging in 4, what's 4 squared? Subtract 2 times 4. Okay, so from the left-hand side, here we go. Okay, so rectangles from the left. The first rectangle will be actually flat. The next rectangle will have a height of 8, because the height of that one was 0. The next rectangle will be 24. The next rectangle will be 48. So that's rectangles from the left. You can obviously see that the area that I'm going to get out of this is going to be way lower than the actual area, right? Okay. So if you want, I'll write it the long way. You don't have to write it the long way. So 0 times 2 is the first rectangle. 8 times 2, 24 times 2, and 48 times 2. Those are the 4 separate rectangles. But really, if you want to do this way shorter, you can GCF a 2 out of all that. Alright, since I did all your work before, you guys have to do this one. Anybody get a good number? 160. Okay, so that's a guess, but it's obviously a low guess. Okay, This one doesn't ask me for the right rectangles. Are we okay, or do you want me to just do it? Or what? Do it? Okay, it doesn't ask, but we're going to do it anyway. Okay, so this time, rectangles from the right-hand side. So I'm actually going to start literally from the right-hand side when I draw them. So that's from 10. So these ones are all going to be above. So it's an overestimation. Okay, we've already done all the front work. So at 10, we were at 80. 8 was 48. 6 was 24. And 4 was 8. Okay, do you understand why I'm using 10 on this one? The height is from 10. Okay, I'm already going to shortcut because they're all too wide. And then I'm going to add the heights. Okay, so those are my estimations. So in my mind, I'm thinking it's probably close-ish to 240. Like that's in the middle, right? Because this is way too low and this is way too high. Okay, so the midpoints, I guess we're going to have to redo all these numbers. Okay, the midpoints, we're going to have to re-input. But I will draw them here. So that's the midpoint kind of drawing. Okay, so all the stuff that we did at the start is not going to help us. So here, do you understand, I'm going to input, so I'm going to cheat here, I'm going to input 3. So when x is 3, our height is 3. When x is 5, my height is 15. When x is, what's the next x value then? 7, 35, and when you plug in a 9, 63. Okay, and then it's just all rectangles again. This is a 2 by 3. This is a 2 by 15. This is a... Okay, this one should be close-ish to our real. So 232 is the area that I'm getting on that one. Okay, trapezoids is the last one. Okay, I know I'm exaggerating my parabola because I had to try to fit them all under here. Okay, so these are the trapezoids. So I don't give you this, so you're going to have to understand, what do you want to call this? The heights, and then you want to do width or base, I don't know, width. Height times width is the formula for a rectangle, but since we don't have a height, we average the height times the width, right? We average the height. Okay, I can do it the long way. You don't have to write it the long way if you already know the short way. So actually I should write this down here. This is a 0, 8, 24, 48, and an 80. Okay, so the first one is the average of 0 and 8 times a width of 2. Second one, so the average height times the width. Okay, because the width is 2, this works. If I don't have a width of 2, by the way, that doesn't work out, right? So if the width is 2, it's good. If it's not, that won't work. So now you're always going to have a single on the end. So 0 and 80 would be singles. And then you'll have 2 8s, 2 24s, and 2 48s. Okay, just the way the formula is simplified. So 160, that does not make sense. Oh, I forgot to add 80. That makes more sense. 240. Does that make sense? Anybody get 240? Okay, you know what I make you do on your test? Double check your answer with the real. How close are we? Okay, so let's, I don't know, I'm running out of room on my page, but I'm going to do the real. So I'm going to anti-derive this. I'm going to go from 2 to 10. Okay, ready? Up 1 is x cubed. Take that divided by 3. Up 1 is squared. 2 divided by 2 is just 1. Okay, so I'm going to do that with respect to... Oops, I already did it. I'm sorry, I wrote this wrong. We'll just do that. Okay, so I'm going to plug a 10 in. Plug a 2 in. Okay, how close are we going to get? My guess is like one of these last ones was probably closer to 30, to 40, something like that. Anybody match when you're done? So the real was 234.67. So we were close on those last two guesses. Okay. Antiderivatives. Okay, so on this, if this is the little f, we're just going to represent it with doing a big F. Okay, so these ones are just to go up a degree and then take what you had and divide it by the new exponent. So, I don't know, didn't need to write that, but 1. Up a degree is a 4. What you had divided by 4. And then this one, if you go up a degree, you have an x. Then you're going to have to add a plus c, because then you don't know if you had something there before you derived it. Okay? By the way, you can always check your answer by taking this and deriving it, right? Because your brain will go better that way. Okay, before I do this next one, I'm going to rewrite Okay, so I rewrote them all. I didn't really like how they looked. Okay, so this one will be a little bit trickier on the math. So if I go up, this will be a 3/2. And then 4 divided by 3/2 is what I will have to do, which is also the same as that, which is 8/3. Okay, next, if I go up, this, be careful, it's negative, so going up is a -2. And then what you had divided by that is -5/2. And then if I go up, it's a 6. If I have 2/5 and divide by 6, it could be the same math as timesing by 1/6. So 2/30. Or you could have done 1/15 if you reduced it, but I don't care if you reduce it or not. Okay. So this one you're going to have to recognize when you have the x on the bottom, that if you tried it the traditional way, it won't work. I'll show you why it doesn't work. So if I tried to do the traditional way and go up an exponent and do this, it causes that to be undefined, right? So what is this rule? You're going to have to just memorize it. ln. So I'm going to test. I'm going to test that. So if I were to derive this, and then you are going to have a rule sheet, and your rule sheet will say u prime over u. So u prime is 1, because the derivative of x is 1, over what the u was. Okay, that's not quite the result I wanted to, so I'm going to have to put a 9 in the front of that. Okay, this I'm going to have to test. What do I think it started with? If it ended up with cos, it started as some kind of sine. Okay, so if I'm trying to derive that, it would be sine 5x times, oops, sorry, cos 5x times 5. This is not that, so I have to deactivate the 5 by putting a what in front? 1/5. Okay, E. I'm going to test. So what would I have started with? An e to the x squared. Something like that. There might be something in front, obviously. Okay, so if I were to derive that, it would be e to the x squared. And then I would attach a 2x. This is not quite what I wanted. So I'm still going to have to times, I need this to turn into that, so I'm going to need to put a 2 in the front. Okay, definite integrals. So those were indefinite integrals, antideriving. So this is a definite when we get a number. Okay, so I'm going to go this symbol to mean I'm actually doing the antiderivative. So I'm going to go up 1 and divide. Up 1, and if that's a 1, so 2 divided by 1. Okay, now we plug in the 6. Subtract and plug in the 2. Okay, so just be careful. I feel like this is kind of where most of the mistakes happen on the test, is just in this math part. So just be careful with your typing. Okay, B. Probably one of these you just have to recognize. What is this one? What happens with the X on the bottom? Remember that if we were to try it, it won't go very well with that. So boom, recognize it's the ln. Okay. Now I'm going to plug in a 5. So the ln of 5 minus the ln of 1. Okay, and then those buttons on your calculator, obviously. Okay, C, there's definitely one of these on your test. So here's the thing to remember on C. 10a is a number. 10a is nothing to do with a variable. 10a is a number. The variable you're dealing with is x. So don't antiderive anything with respect to a. Okay, so if you have a number, so pretend like 2, how do you antiderive it? You put an x on the end of it. So 10a is the number. Now it will have an x on it. This, I'm going to go up a degree, 6 divided by 2. Reminder?
Yeah.
Grad pictures, probably.
No.
Okay, so this is me plugging in 3a to the x spot. Are you okay to understand that the whole plug in 0 will just be 0? You okay with that? I'm not going to plug it in. Okay, guess where I would catch people? I bet you I would catch people doing their math on this. Because don't forget, you have to square the 3. So 9, and then times the 3. So this That's where I would probably catch people forgetting to do the square on the 3. Okay? So just be careful on the math part of it. And that's your answer. Okay, so don't derive with respect to A. Make sure you think of that piece as just a number. The what? Ellen?
When you do the LN stuff.
It shouldn't matter. No, it has nothing to do with trig. Yeah, that shouldn't. Okay, so some harder ones. Let's try some tests. Okay, so my guess is I started with this unit to the 8th. That's what I'm going to guess I started with. Okay, so now I have to remember the chain rule. 8 units to the 7th. See where I'm getting that from? 8 units to the 7th times the derivative of the unit. Okay, so 8 times 45 is 360. Okay, I didn't quite turn out how I wanted to. So 360 is going to need to get multiplied by what? I have to turn it into a 35. So you're going to have to multiply it by 35 over 360. Okay, next, I'm guessing I started with a cos 7x to the 5th. Are you okay kind of understanding why I'm picking what I'm picking? To end up with the unit to the 4th, I would have started with the unit to the 5th. Okay, so I'm going to derive this. So 5 units to the 4th times the derivative of the unit. So do you remember cos derives to negative sign? Then you still have to attach the derivative of that unit. Okay, I need to turn this into a 5. So I'm going to have to, you can write that, or you can do negative 1/7. Doesn't matter to me. Okay, and again, you're your best friend here at the end. You can just drive this. Does it work out to what you wanted it to be? Okay, and C, you're going to recognize this as an ln. So we're going to test the ln of u. We're going to test that. The ln of u. Okay, so if I derive it, I get u prime So 9x squared plus 8x over u. Did that end up how I wanted it to? Not quite. This top needs to get doubled. So I'm going to put a 2 in the front of what I did. Okay, so figure out what you want to test. Do your derivative. What do you need to put in the front of it? Okay, finding an area under a curve. So this is you making sure you set it up properly. So this is how it should look. This means finding the area. Doing the integral from 1 to 4 is finding the area. Now I'm going to use this symbol to represent me actually doing an antiderivative. So up 1, divide. Up 1, divide. Okay, I'm going to plug in a 4. And then I'm plugging in a 1. We're good? That one, 240. Okay, next. Find the area between that curve and the x-axis. So this type, I don't have my numbers, so I actually have to figure out where does it equal the x-axis. So 0 equals, and then I'm going to recognize that I have to simple trinomial. Okay, so there's my simple trinomial. Okay, I think on your test I make you draw a sketch. So what do you know here? This is my sketch. That's a parabola. I know that's where it's hitting the x-axis. So I'm finding the area in this zone. What do you think my answer is going to come out to be? Negative. I can see my answer is going to come out to be negative because the area will be under there, under the x-axis, but I'm just going to change it at the end. So here's what I'm going to do. The integral So the integral of that equation from -4 to 2, now I'm actually going to antiderive it. So go up, divide, up, divide, up. Okay, so plug in a 2. And then you're going to have to plug in a -4. Okay, I'm going to cheat. I'm going to write these down for you. So this answer would come out to be negative 36 in your calculator when you did it. And this is why it's not, don't panic, it's negative. The reason is because it's below the x-axis. That's why it's negative. But your answer should be area equals 36 when you're done.
Do you want us to write a huge square?
I'm okay if you don't, but. Okay, last question. This will be the last type. Find the area between two things. So you'll have some of those. Okay, so where does this equal this? So probably understand this is a cubic and a parabola. I might have a parabola and a line. So remember how to graph those. Okay, so to solve this, my algebra stuff is to zero it out and factor with a GCF. And then a simple probably wouldn't make you draw this one. This one I probably wouldn't, but I probably will have like a parabola and a line crossing each other where you kind of have to draw. Okay, so this is a parabola that has x-intercepts like that. I don't know, that's what's going on, but the cubic looks like that, kinda. That's the cubic. Okay. Oh, Ethan, I'm sorry, we can't double this one, I don't think, hey? They're not gonna be the same. This and this, sometimes we're symmetrical on us, but this one's not. So you're gonna have to separate them. The 0, or let's go from -3 to 0. And then we'll also be doing from 0 to 4. Okay, I'll do it the long way. If you want to do it the short way, that's fine. So this one, I'm going to do the quadratic subtract the cubic. Okay, you could also write that together. If I wrote that together, that would also work. Okay, if I did that together, it will also work. Okay, so in this section, it would make also the same sense to do the quadratic minus the cubic. Okay, I'm not going to carry this one out with you. It would take a while. I'm sure you can, it's the same idea, but what am I going to do with my final answer? Because this is area 1 and this is area 2. What do you want to do with those two values when we're done? You'll want to add them because the full area is the area of this section plus the area of that section, right? When you would be all done. What's that?
Could you not in theory just do 4 and then negative 3 the same because you have 0?
They're two different sections. You have to separate those two sections.
Oh, well then
It's-
it's a happy accident that mine worked.
Yeah, probably.
For the second area, isn't it gonna be like 0 minus something? So then, would you like, well, just like for that one, would you just make both answers positive and then before you add them?
Yeah, yeah, because this one would be negative mathematically. Yeah. So let's pretend you got a negative 20 and this you got a 40. You would say your area is 60. Yeah, like that. Is that what you mean? Yeah. Okay. Just be careful here. If you accidentally did it backwards, it's okay. And you were doing the area of the cubic minus the area of the line or the quadratic. Okay? It's okay if you did it backwards, but just be careful because that would have been a common mistake. Okay? If you do it backwards, your areas will come out negative sometimes or whatever. Just whatever you get for your area, just always change it to positive because that's